Okay, so we've talked about multiplication of matrices with vectors. Now we're going to talk about multiplication of matrices with matrices. And this is what we call full-blown matrix multiplication. So let's go on to the definition. Definition of matrix multiplication. Basically, the idea is that we know how to multiply a matrix by a column vector. So consider the first matrix and then consider the second matrix as a set of column vectors. Okay, so the first column of the result is going to be the matrix A times the first column of matrix B. And we know how to do that because we know how to find the product of a matrix with a column vector. The second column of the result will be the matrix A multiplied by the second vector, column vector of B. Third column of the result is the matrix A multiplied by the third column of B, and so on down the list. Okay, so we're just building up the definition of matrix multiplication by using the definition of matrix vector multiplication. Let's look at this example here. So understand this carefully. Here's our first matrix A. Now notice this matrix is 3 by 5. And here's another matrix B, which is 5 by 4. 5 rows and 4 columns. Notice this 5 is the same as that 5. That's no accident. Now, according to the prescription that I just gave, the first column of the result should be obtained by taking the matrix A, the full matrix A, times the first column of B. Okay, if I take this full matrix A times this first column of B, that will give me a column vector. That's going to give me a linear combination of the columns of A. Now, what size vector will that be? Well, each column of A is a 3 long vector. So when I take a linear combination of those columns, I'm going to get a 3 long vector. All right. Now, the computations aren't done here, but we've done this many times before. You can verify that this vector times this matrix gives you this vector here. Okay, so this vector gives me the first one. To continue to get the second column of the product matrix, to get the second column, I need to take the matrix A times the second column here. And similarly, that's going to give me a 3-component column vector. Continue. Third column of the result is going to be the matrix A times this third column. Fourth column of the result is matrix A times the fourth column. Okay, so what's the size of the resulting matrix? Think about how we did this. The number of entries in each column is going to be the same as the number of entries in the columns of A. Okay, each column of A had 3 entries, so the resulting matrix is going to have 3 rows. So the dimension here is 3. Okay, how many columns does the result A times B have? Well, notice for each column of B, we generated a different column of A times B. So the number of columns is going to be 4. This is a general rule that the number of rows of the product is equal to the number of rows of A, and the number of columns of the product is equal to the number of columns of B. That's a general rule. The other thing that's important is that the number of columns of A must be equal to the number of rows of B. Otherwise, you can't do the product of A with the column of B. Okay. All right, so here's some examples. We can look at how these work. If you want to do this example, think about how to do AB. Work this through and see how this works. AB, the way you get AB, it's going to be the matrix A times the first column, which is 4, 5. And that's going to give me the first column of the result. Let's see how that works out. If I take the matrix A times 4, 5, it's going to be 4 times 1 minus 1 plus 5. 5 times what? Plus 5 times 3, 2. Okay. If I work this out, a times 4, 5, I'm going to get 4 times 1 minus 1 plus 5 times 3, 2. Let's work this out. It's going to be 4 minus 4 plus 1510 okay, and so that's going to give me 4 plus 15, which is 19, and that's why I get a 19 here, and I get minus 4 plus 10, which is 6, and that's why I get a 6 here. So this a times 4, 5 gives me this result here, this 19, 6. Okay. To get the second column, similarly, you could work out a times 0, 1. And if you think about what happens when you take a times 0, 1, this is 0 times the first column of a plus 1 times the second column of a. So this is just equal to the second column of a, which is 3, 2. Okay, so that's where this second column comes from, this 3, 2. All right. So you'll have to do several examples of this to see how this works, but that's how you compute it. BA, in this case, you take B and multiply by the successive columns of A, and you'll get this result. Notice these two are not the same. Not the same. Very important example of an operation that's not commutative. Okay, it's not commutative. Okay, so make sure that when you multiply matrices, you get the order correctly. Sometimes you have a matrix equation and you multiply both sides by a matrix. You have to multiply both sides on the same side. Okay, so that's matrix multiplication. Now there's another way to do matrix multiplication, which may be the way that you've been taught. Okay. In this method, we've been generating the multiplication of two matrices column by column. We take the first matrix times the first column and then the first matrix times the second column, etc. Now you can do matrix multiplication entry by entry. And the formula is here. What this basically means is that to get the ij entry of the product, you take the ith row of the first matrix and the jth row of the second matrix, jth column of the second matrix, jth column of the second matrix, and inner product them together. All right, so here's the formula. And there's a proof here that this agrees with the method that we've been using. But let's just go ahead and do an example. All right, so here's A and B. A is a 3 by 5 matrix. And B is a 5 by 4 matrix. Okay, like before. So our result should be 3 by 4. Now, let's suppose we want the 2, 3 entry of the result. We want just the 2, 3 entry. That's the second row and the third column. The way to get that is take the second row of A and the third column of B and inner product them together. 0 times 2 plus minus 4 times 3 plus 1 times 2 plus 2 times minus 1 plus 3 times 3. Okay, here's written out in index notation, and here's the result, and you just do this arithmetic and get the result. Here's another example. If I want the third row and first column, that means I should take the third row here, third row of A, first column of B, and do the inner product. Minus 5 times 1, plus 1 times minus 1, plus 2 times 1, plus minus 3 times 6, plus 4 times 1. So see how these go together. First goes with first, second goes with second, third goes with third, fourth goes with fourth, fifth goes with fifth. You multiply those, add them together to get your result. Okay, so this is very useful if I only want one entry of the matrix. And this is the usual way that people compute matrix multiplication, if they compute by hand. All right.